We're going to continue chapter 9, solving systems by elimination. All right, these are the steps to do elimination. Again, it's easiest if I just do them, but in words, this is how we would do it, right? I always line up the x, the y's, and the constants. You always want matching opposite coefficients. If you don't have that, you can change one or both of the equations, so that way you have a variable that cancels out, right? So that you eliminate one. And then whatever you have left over should just be one variable, and you just solve that equation, plug it into one of the two equations, and you solve. All right, so if you look at the first one, we're looking specifically in elimination for opposite coefficients, right? Between 3x and 5x, there's nothing special about that. But with the 2y and a negative 2y, right, those are the same number and they are opposites, meaning we can go ahead and combine these. All right, if I go ahead and combine these, then the 2y minus 2y is going to cancel out, but everything else is going to give us something pretty simple that we can solve for x, right? So if I did 3x plus 5x, that's going to get me an 8x. If I did 4 plus 12, that's 16. Right, and then you can go ahead and divide both sides by 8, and then you very simply get x equals 2. All right. If you would try to substitute here, you would still get that same answer, just it might be a little bit harder, right? Because these don't substitute nicely, right? If you try to get one of your variables isolated, you might end up with some fractions, and then which aren't super difficult, but I mean it's not ideal in this case. All right, so now with this x equals 2, what you can go ahead and do is you can plug it into one of your two equations. It doesn't matter which one. So unlike substitution, there's not an obvious choice, right? You can pick one of your two equations, right? So I'm going to plug it into the first one. So this is going to be 3 times 2 plus 2y, and this equals 4. And then 3 times 2 is 6. And then you can subtract 6 on both sides, and so I get a 2y equals negative 2. Divide both sides by 2, and I get y equals negative 1. And then once again, you always want to write your answer as an ordered pair. Right, so 2 comma negative 1. All right, we keep going. This one, another one where you have opposite coefficients. So 2x and 2x, notice that those are the same, but they're not opposites, right? So you can still, there's a way to eliminate the x, but it's easiest to do it if you have already a pair of opposite coefficients, right? So not just the same number, but opposite sign as well. And then notice here in front of the y, treat that as a 1, treat that as a 1. I get a 1y and a minus y, minus 1y. And then those are already opposite coefficients, so when you go to combine them, they cancel out. And then 2x plus 2x is going to get you 4x. 4 minus 1 is going to get you a 3. So then very simply, to get x, just divide both sides by 4. And so you get x is 3/4. Once again, you can plug this into one of your two equations. I can plug it into the first one, and then that's going to get us a 2 times 3/4 plus y equals 4. 2/4 is going to simplify. That 4 on the bottom is going to become a 2. And then so you end up with 3/2 plus y equals 4. And then I can subtract 3/2 on both sides. And then I get y is 4 minus 3/2. All right, and then I'm going to write this over 1. We want a common denominator. So this is going to get us 8 over 2 minus 3 over 2, which is 5 over 2. And that's our answer for y. So then our answer as an ordered pair is going to be x comma y, so 3/4 comma 5/2. All right. So if you look at the next one, we don't have opposite coefficients, but we do have opposite coefficients, right? So I have a negative 4y and a plus y, right? They're already opposites. We want to see if maybe we can make these the same, right? So I want to make the numbers match. The only way that I can get a 4 out of a 1 is if I multiply it by 4, right? So this is a case where you can multiply one of your two equations by a number. All right, and in this case, I can multiply it by 4, and I get 20x plus 4y equals negative 4. All right, I'm just going to rewrite the first equation, just so that you can clearly see what cancels out. And this is going to equal negative 7. All right, and then when you go to combine these, all right, negative 4 minus 7 is going to get you negative 11, right? 4y minus 4y is going to cancel out, and you're going to get 22x when you add. All right, and then from here, you can divide both sides by 22, and then I get x is negative 1/2, right, when you simplify. And then so you can plug that into one of your two equations, doesn't matter which one. All right, so if I plug it into the first one, you get 2 times negative 1/2 minus 4y equals negative 7. The 2's cancel out, so I get a negative 1 minus 4y equals negative 7. I can add 1 on both sides, so I get a negative 4y equals negative 6. Divide by negative 4, and negative y equals 3/2. All right, the negatives cancel out, and then 6 and 4 simplify. So then your final answer as an ordered pair is going to be negative 1/2, comma 3/2. All right. Now if you look at the next one, same exact scenario. Right, we want to see what we can do to one or both of these equations to get the coefficients to match. All right, so we can get the second equation to match the first one by multiplying by 3. All right, if I do that, then I get a 15x minus 3y equals 51. All right, and then if I write the first equation right underneath, you can clearly see that the 3y's are going to cancel out. All right, so you're always going to look at your two equations, and you're going to see which one gets you closer to eliminating a variable in the least amount of steps, right? So you could have eliminated x, but then you would have to eliminate both of the equations to get them to match, right? So make it easier for yourself. Try to observe both variables before you decide what to do. And then doing this, the y's cancel out. 15x plus 2x is 17x. 51 plus 17 is 68. Divide by 17, and then I get x equals 4. All right, and then this x equals 4 you can plug in to one of your two equations, doesn't matter which one. So I'm going to get a 2 times 4 plus 3y equals 17, so I get an 8 plus 3y equals 17, and then just simply solve for y. So I can subtract 8 and then divide by 3. So I get a y equals 3. All right, and then so my answer as an ordered pair is going to be x comma y, so 4 comma 3. All right, so let's continue. If you look at this one, you notice that it's not really convenient to multiply one of your equations by a number to get it to match the variable of another one. Sometimes you'll have to multiply both of them, right, which is fine. It's the same exact process. You just have to do it to 2 instead of 1, right? So if you look at the first and the second, between x and y, it looks like it might be easier to eliminate y just because they already have opposite signs, right? So then that means all you have to do is just change the number, right? So if I multiply the top one by 4, the bottom one by 3, that'll get you the exact same number, right? So you always want to look for the least common multiple between the two numbers that you're trying to get to be the same. So between 3 and 4, their least common multiple is 12, right? So least common multiple meaning 3, 6, 9, 12, 15, and with 4, 4, 8, 12, 16, 20, so on, right? 12 is the least one. All right, so then I can go ahead and distribute that 4 to everything, and then we end up with a 20x plus 12y equals 36. All right, and the second one, if you distribute that 3, you end up with a 6x minus 12y equals, that'll get you 42. All right, and then so when you go to combine these, 20x plus 6x is going to get you 26x. 12y minus 12y cancels out. This is going to equal 78. And then very simply, you just need to get one of your variables alone, right? So just divide by 26, and then you get x is 3 in this case. So if you get x is 3, plug it into one of your two equations. Doesn't really matter which one. I'll do the second one. All right, so we get 2 times 3 minus 4y equals 14. 2 times 3 is 6. 6 minus 4y equals 14. You can subtract 6 on both sides, and we get negative 4y equals, what is that, 8? And then divide both sides by negative 4. And then so you get x equals negative 2. I'm sorry, y equals negative 2. All right. And then so your answer as an ordered pair would be x comma y, so 3 comma negative 2. All right. We can do the same thing with the next one. Once again, it doesn't really look like we can just multiply one equation to get them to match. We can multiply both of them, right? So this is a case where we have to do both. And it also looks like none of our signs are opposites. So there's not really a more convenient one to do in this case. But let's try eliminating x. All right, so if you try eliminating x, between 3x and 2x, the least common multiples of 2 are 2, 4, 6, 8, 10. All right, 3 is going to get you 3, 6, 9, 12, and so on. The least common multiple that they share is going to be 6, right? So I want to make sure to get a 6. So I'll multiply this one by 2. And then if I have that one multiplied by 2, I want to multiply the bottom one by 3. And if it's 1 is positive, I want 1 to be negative, so I'm going to multiply by a negative 3. So let's multiply by 2 everywhere. So I'm going to distribute that 2 to everything, and we get 6x plus 4y equals 14. Let's distribute that negative 3, and we're going to get a negative 6x minus 15y equals negative 3. All right, and then so you can go ahead and simplify. The 6x and the minus 6x are going to cancel, and then you end up with negative 11y equals 11. Divide both sides by negative 11, and we get y equals negative 1. All right, and then so to get your other variable, plug it into one of your two equations. Doesn't really matter which one. I'll do the first one. It's going to be 3x plus 2 times negative 1 equals 7. It's going to get you a 3x minus 2 equals 7. We can add 2 on both sides, and we get 3x equals 9. And you can divide both sides by 3, and then you get x equals 3. All right, and then so your ordered pair is going to be 3 comma negative 1. All right. Now, for something like this one with decimals, right, I showed you guys how to handle that in the previous lesson. Anytime you have decimals, you want to get rid of them completely. So you can think of it as like you're multiplying everything by a constant, so 100. But you can also just think of it like you're moving all of your decimal places twice. Right? So if you move all of your decimal places over the same amount of times, then it's going to get you much simpler whole numbers. So we get 2x minus 5y equals negative 38. Right? And then we get 3x plus 4y equals 104. All right, so now we can treat it just like any other problem that we've done before. All right, so we can try to eliminate one of our variables, x or y. I would do, again, I always pick the one that already has opposite signs in the variable, right? In this case, that's going to be y. All right, so I'm going to multiply the top equation by 4, the bottom equation by 5. All right, and we do this so that the y's not only have the same sign, but that they match numbers as well. All right, so if I distribute 4 to everything, this is going to get you 8x minus 20y equals 38 times 4 should get you negative 152. All right, and then if I distribute 5 to the second equation, all right, that's going to get me 15x plus 20y, and this should get you 520. All right, and then when you go to combine these, 8x plus 15x is going to get you, what is that, 23x? Equals, and then negative 152 plus 520 gets you 368. So divide both sides by 23. Right, we'll give you more manageable stuff on the test, right? But just to show you that you get an answer from this, this should get you, let me see what that gets you. All right, 16 for x. And then you can plug that into one of your two equations, right? Whatever is simpler. All right, so if I do that, let's say into this equation, that's going to get us 2 times 16 minus 5y equals negative 38. And then I get 32 minus 5y equals negative 38. And then I can subtract 32 on both sides. And then I get negative 5y is negative 70. And then divide by negative 5. And then I get y equals 14. All right, so then your ordered pair is going to be 16, 14. Again, you'll have more manageable stuff on the test, but just to show you, you do get an answer. Let's continue. So again, you always want to make sure that you can eliminate one of your two variables, right? But if you notice in this case, right, let's say I wanted to try to eliminate x, right? They already have opposite signs, so then all you have to do is multiply the top equation by 2. And if you do that, you end up with 2x minus 4y equals 6. All right, so now not only does the x combine like we wanted it to, but also the y's combine, and you can simplify everything to 0. So we're just left with 0 on this side. And then 1 plus 6 in this case is going to get you a 7. All right, so 0 equals 7. This is not a true statement. False. Anytime you have a false statement, this is no solution. All right. So on a graph, this might just look something like you have two lines that don't intersect. Right? So if this is our graph, you might have a line that looks something like that, and a line that looks something like that. All right, so I'm not going to do the graphing section, but I will just finish these examples for you guys. So again, same exact thing as before. Let's try to eliminate one of our variables. If I try to eliminate x in this case, you can distribute 2 to everything to get the same opposite coefficients. So you get 12x minus 10y equals 6. And then negative 12x plus 12x goes away. And then everything goes away, actually. So we end up with 0 equals 5 plus 6 is 11. This is also not a true statement, so this is a no solution. All right. And then number 10, right? Similar story happens here, right? If I want to try to get everything to match, right? Let's say I wanted to multiply this equation by negative 2. Right, then we end up with a negative 4x plus 2y equals negative 2. Everything cancels out here, I get 0, but on the other side I get 0. 0 does equal 0, this is true, right? So this is an infinitely many solutions. I'll just say infinite solutions. All right, so not always if the variables cancel out is it no solutions, sometimes it's infinitely many. All right. Now, sometimes if you get fractions, right, I showed you guys way back how to handle the fractions. All you need to do is multiply by a common denominator. Between 2, 8, and 8, a common denominator is going to be 8. If I distribute 8 everywhere, 8 times a half is 4x. 8 times negative 1/8 is just negative 1, so I just get a negative y. 8 times negative 3/8 is going to be a negative 3. All right, and then once again, everything cancels here. I get a 0 on one side, and on the other side, I also get a 0. All right, and that is a true statement, so this is infinitely many solutions. All right, in an infinite solutions case, that just might look like 2 lines, one right on top of the other. All right, they're the exact same line. All right, and then that's all the cases that you're going to see with elimination.